Hi everyone, today we will revise all past paper questions from 2016 to 2024 related to chapter 8 rates of reaction. Okay, before starting this chapter and the questions related to this chapter, I will give you a brief introduction about this chapter and we will see what are the factors that actually affect the rate of reaction. So our topic is actually rates of reaction, right? So there are three major things that can affect the rate of reaction. One is concentration, okay, and the second is temperature, and third is catalyst. Okay. In concentration, we have three types based on the state of the matter. If our reactants are solid, then what matters actually? The surface area. The surface area of the reactant actually matters. And if our reactant is a solution or a liquid, its concentration actually matters. If high concentration, the rate of reaction will increase. If higher the surface area or larger the surface area, the rate of reaction will increase. And if we have gases in our reactants, then pressure actually is the main component that will decide the rate of reaction. Higher the pressure, higher the rate of reaction will be, okay? Higher the temperature, higher the rate of reaction. Okay, and the addition of catalyst will also increase the rate of reaction. So all these things actually increase the rate of the reaction. So now let's see one by one for concentration, okay? We will see for concentration, if we have reactants as a solid, then their surface area matter. What does surface area means? It means that the particle size, if it is smaller, if the size of the particle is smaller, it means it has a large surface area, okay? So particle size smaller, it means the rate of the reaction will increase. That's why when you are using a powder reactant or maybe a lump of the reactant, then the powder reactant will have a higher rate of reaction compared to that of the lump of that reactant you are using. And what is actually the rate of reaction? Rate means the speed of the reaction, right, per unit time. We want to see, and how we can calculate this rate of reaction? We can calculate the rate of reaction by looking at the products, how much time the products are, like how much time the products are taking to be made, okay? If they are taking 15 seconds or 20 seconds, okay? If we get the product within 15 seconds, it means this rate of reaction is higher than the one that is just taking 20 seconds, right? And the second thing, we can also measure how much time a reactant is taking to be consumed up, okay? All the reactant that has been consumed, how much time it is taking, that is also that will also decide the rate of reaction. So it depends which thing you are looking at. Either you are looking at the formation of the product or how much reactants are consumed, okay? So this is all related to this chapter. Now we will see one by one each question, and I will then explain you why, which factor is actually affecting the rate of reaction. So let's come towards question 1. Which changes increase the rate of reaction? So increasing the concentration of the reactant. Yes, if you increase the concentration of the reactant, it will increase the rate of reaction. Increasing the particle size of the solid reactant. No, it will not increase the rate of reaction. It will decrease the rate of reaction, because I already told you increasing the surface area will increase the solid reactant, the rate of reaction, right? But here they are increasing the particle size. So if you increase the particle size, it means you are decreasing the surface area. So that's why this option is wrong. Increasing the temperature, yes, that's right. So option 1 and 3 are the correct option only. So option C is the right option. Let's see question number 2. In an experiment, a nitric acid is added to excess marble chips and the volume of carbon dioxide formed is measured. So what are they actually measuring? They are measuring the product, right? So we have to see how much product is formed at a given time. The experiment is repeated using smaller marble chips, okay? Before they use the marble chips and then later they use smaller marble chips. So it means they decrease the particle size. If they decrease the particle size, it means they have increased the surface area, right? Increase the surface area. Okay, so all other conditions remain the same. So now which statement about the second experiment is correct? So in second experiment, if you increase the particle size, the rate of reaction of course will increase. What is the reason behind increasing the particle size, or decreasing the particle size or increasing the surface area. Okay, so if you increase the surface area, actually what happens, the number of collision actually increase. Okay, the number of collision will increase. That's why the rate of the reaction will increase. So increasing the surface area always increase the number of collision. There is no other reason behind this. Okay, only one reason, that is actually the number of the collision will increase. So we have to find that answer here. The collisions are more frequent, yes, and higher energy. That is wrong. The energy will not change, only the collision will increase. Okay, so this option is not right. The collisions are more frequent and the same energy. Yes, this option is right. The energy will be same, but only the number of the collision will increase by increasing the surface area of the reactants. Okay, so that's why option B is the right option. Okay, question number 3. Magnesium reacts with hydrochloric acid to form magnesium chloride and hydrogen. Why does magnesium powder react faster than magnesium ribbon? So if they use the powder and if they use the ribbon, of course the magnesium powder, the rate of reaction will be faster. So what is the reason behind it? Because the powder has small particles, right? Now small particles means the higher the surface area. So the surface area has been increased. So when the surface area is increased, it means the number of the collisions will be more. So let's see the answers. The magnesium atoms in the powder have lower activation energy. Wrong. It has nothing to do with the activation energy. These are the reactants, right? The solid particles. Now, if you increase the surface area, what will happen? Only the number of particle collision will increase. That is only the reason. So we have to find that reason. The powder has a smaller surface area. That's wrong. Powder has a larger surface area. Increasing the surface area actually increase the rate of reaction. The magnesium atoms in the powder have more frequent collision with acid particles. Yes, that is the right answer. Now magnesium atoms, because they are now in the powder form, they have more surface area, so there are more collisions. Okay, the magnesium atoms in the powder have greater kinetic energy. That's also wrong, because the increasing the surface area has nothing to do with the energy. Okay, it is just that the number of collision will be increased. So that's why option C is the only right option. Question 4. A sign display in a flour mill is shown. Which statement explain why there is a danger of explosion in the flour mill? So you know that when we are making the flour particles are very small. So the size of the particle, if it is small, then it means they are taking a lot of space. So they have higher surface area. So that's why there is a more chance of the explosion. Okay. Flour burns very quickly because it is a fine powder. Yes, that's the right answer. Because it's a very fine powder, it has a higher surface area, so of course any explosion can help it to burn easily. That's why flour burns very quickly, because it's a fine powder. So option A is the right answer. Why option B is not right? Flour is a catalyst for combustion. That's wrong. Flour is a reactant. Flour mills get hot and speed up the rate of combustion. Wrong. The combustion of flour is exothermic. These are not the reason. Actually, because flour is a very fine powder, so that's why it will increase the rate of reaction, and that's why when there is a small fire in these flour mills, it will turn into explosion. Why explosion? Because of those fine powder. So that's why option A is the right option. Question 5. Which statement explain why coal dust forms an explosive mixture with air? So many people who are working in the coal mines, there are so many disasters happen like this explosion. Why they die? It's all because of the coal dust. Okay, the coal dust, okay, or small fire can create a big explosion. So what is the reason? It's also the same reason. Coal is a solid. Okay, so dust particles will have more surface area. So more surface area will increase the rate of reaction. So whenever there is a fire, a small, it will turn into explosion. Why? Because of this more surface area. So the rate of the reaction will increase. So let's see what is the reason behind it. Coal dust catalyzes the explosion. Wrong. Coal dust is actually itself a reactant. Okay, it's not a catalyst. Coal dust has a large surface area. Yes, that's right. Coal dust, because they are very small particles, so they have the largest surface area. They will take more space, right? So option B is the right option. Question number 6. Which statement explain why increasing the concentration of a reactant increases the rate of reaction? So now this question is related to concentration of the reactant. It means we are talking about a solution. Again, now if you increase the concentration of the reactants, for surface area, I already told you there will be more number of collisions, right? More number of collision. But why in concentration the rate of reaction increases? Because now we have more number of particles in a same volume, more number of particles in a small volume, right? So the particles numbers increase. in a smaller volume. That's why the rate of the reaction will increase. Now, when you have more particles in smaller volume, then there will be more chances of collision, right? That's why if you increase the concentration, the rate of the reaction will increase. Let's see, a great proportion of the particles have the activation energy. No, that's wrong. It has nothing to do with the activation energy. Only we have more number of the particles, okay? So this is wrong. Particles have more energy, again wrong. It has nothing to do with the energy. There are more particles in the same volume, so there are more frequent collision. Yes, this option is right. More concentration means that in a small volume now you have more number of the particles. So this option is the right option. Option C is the correct option, okay? The particles move more quickly. No, the speed of the particle depends on the temperature. If you increase the temperature, then particles move more quickly. So this is also not the reason. So option C is the only right option here. Question 7. Which statement explain why increasing the concentration of a reactant increase the rate of reaction? So I already told you, let's see this one once again. It increases the collision rate of the particles. Of course, yes, the collision rate of the particles will increase when you increase the concentration. It lowers the activation energy. Wrong. Only catalyst can lower the activation energy. It is the job of the catalyst. No other temperature, concentration or surface area, they cannot lower the activation energy. Only catalyst actually lowers the activation energy, okay? So this option is wrong. A greater proportion of the colliding particles have the required activation energy. Again wrong. How we know that? It's only the concentration is responsible for more particles number. Okay, so there are more particles, so there are more chances of collision. These are the only reason. More particles in a small volume, and then we have more chances of collision. So that's why the rate of reaction will increase. So there are more particles per unit volume. Yes, that option is right. So option 1 and 4 are the only right options. So option B is the correct option. Question 8. Dilute hydrochloric acid reacts with 1 gram of limestone. Which condition produces the fastest rate of reaction? So now we are using dilute hydrochloric acid, and then we have also another reactant is our solid. So for solid, if you want to increase the rate of reaction, it should have the high surface area, right? High surface area, how we can get high surface area or more surface area? If the particle size of the limestone will be smaller particle size, right? And how we can increase the rate of reaction? If we have dilute HCl, we can increase the concentration of this one. If you increase the concentration, high the concentration, the rate of the reaction will increase. So now we can see how, which conditions will increase the rate of reaction. 2 mole per dm cube of hydrochloric acid, okay, 4 mole dm cube of hydrochloric acid, 4 mole dm. So these are the three that have the highest concentration, right? So we have to choose anything from here. Now let's see for the high surface area. And a single lump of limestone or small pieces of limestone. So this is the right answer, or this is the right answer. Powder limestone, okay. Single lump is not the right answer because the particle size is big. When the particle size is big, it means the surface area is smaller, so it will not increase the rate of reaction. So these two options are not right. Now these two options are correct, but we have to choose the one, which one is the best one, because small pieces of limestone, or which one will have more surface area, or if you are just using the powder one, so it means the powder one are more smaller than that small pieces, right? So it means it will have more larger surface area compared to this one. So that's why option D is the right option. Question 9. Four statements about the effect of increasing temperature on a reaction are shown. Now they are talking about increasing the temperature. So increasing the temperature, how the rate of reaction will increase. Okay, so for temperature, actually how the rate of reaction increase? First, the heat will provide more kinetic energy to the particles. More kinetic energy, okay, for the particles now. So what will happen? Higher the speed of the particles. Now the particle speed will increase. So once the particle speed increase, there will be more number of collisions, and the fourth thing that is most important is that heat also increase the energy of the particles. Last time we discussed that activation energy is the minimum energy to start a chemical reaction. For example, there is a chemical reaction that needs 300 joules of energy, right, to start a reaction. So what the temperature will do, actually, it will increase the particles energy. So most of the particles will have now 300 energy or more than 300, so that they can give you a successful product. Okay, so that's why temperature also increase the energy of the particles, not the reaction rate, not the reaction energy, but the particles energy. Okay, so increasing the temperature do what? It increase the kinetic energy of the particles, and also it also increase the speed of the reaction. The chances of the collisions are more, and when the chances of collision are more, they are more successful collision, because more particles have the higher energy than the activation energy. So the activation energy becomes lower. That's wrong. It's only right for the catalyst. Temperature has nothing to do with the activation energy. It will just increase the energy of the particles, not of the reaction. The particles move faster. Yes, that's right. There are more collision between reacting particles. Yes, because when the particles move faster, they will collide faster. And when collide faster, of course, there are more collision. There are more collisions which have energy greater than the activation energy. Yes, this statement is only right for the temperature, not for concentration, not for the gas pressure, and also not for the surface area of the solid. Okay, this statement is only right for the temperature, that there are more collisions which have energy greater than the activation energy. So that's why we are left with 2, 3, and 4. Okay, so all the 2, 3, and 4 options are right, and that is option C. Question 10. Which statement explain why increasing the temperature change the rate of the chemical reaction? It increases the activation energy. That's wrong. It has nothing to do with the activation energy. It increases the particles energy. Okay. It increases the frequency of the collision between the reactant particles. Yes, the collision will be more. It increases the kinetic energy of the reactant particles. Yes, that's right. It increases the kinetic energy. It increases the number of particles per unit volume. Wrong. It has nothing to do with the increase in the number of particles per unit volume. That is actually happening in concentration, right? When you increase the concentration, the particles number increase. So only option 2 and 3 is right. That is option C. Question 11. Which statement explain why increasing temperature increase the rate of chemical reaction? Again, heat makes the molecules move faster and collide more often. Yes, when you increase the temperature, the particles will move faster because of more kinetic energy, and they will collide more often. Heat makes the molecule collide with more energy, so they are more likely to react. Yes, that's right. That is only right for temperature. That now the particles, the molecules or the particles, colliding particles will have more energy. Increasing temperature lowers the activation energy. Wrong. Temperature has nothing to do with the activation energy. It's only the catalyst that will lower the activation energy of the reaction. So option 1 and 2 are only the right options. So that's why option A is correct. Question number 12. Which statement about the effect of increasing the temperature on the rate of the reaction are correct? Again, effect of increasing the temperature. So increases the rate of reaction? Yes. It increases the activation energy? Wrong. It has nothing to do with that. It increases the frequency of collision? Yes. It increases the chances of collision, because now we have more chances, because the particles are moving faster, so there are more chances of their collision. So more frequency of the collision will be successful. So option 1 and 3 are the right option. That is option C. Question 13. Ethanoic acid reacts slowly with calcium carbonate. Okay, so one is solution and the other one is now solid. Which statement explain why an increase in temperature increase the rate of reaction? Okay, so they are asking about the temperature. Nothing we have to do with the concentration. The activation energy of the reaction is decreased. Wrong. Again, temperature has nothing to do with activation energy. Remember that. There is an increase in collision rate. Yes. The particles have more energy. Yes, this is the only right for temperature. There will be fewer successful collision. Wrong. If the collision rate will increase and the energy will also increase, so there will be higher successful collision. So option 4 is wrong. Only we are left with option 2 and 3. So 2 and 3, it means option C is the right option. Question number 14. Which change in condition increase the energy of the particles in a reaction? So which change, I already told you that energy increase in energy is only related to temperature, not to any other thing like the pressure or maybe the concentration. No, No other thing is responsible for the increase in the energy of the particles, okay? So it's only the temperature. So that's why option D is the right option. Which change in reaction conditions increase both the collision rate and the proportion of molecules with sufficient energy to react? Collision rate. Who will increase the, which factors are responsible for increasing the collision rate? So we already know concentration will increase the collision rate. Everything like, okay, concentration, then we have a pressure, we have surface area, also we have temperature. They all will increase the collision rate, right? Not the catalyst. Catalyst will not increase the collision rate, it will just reduce the activation energy, so more successful collision will be there, but collision rate will be same, okay? So these are the four things that are responsible for this, okay? But the proportion of the molecules with sufficient energy to react. Now, this proportion of the molecules, if it increase, it's only the temperature that is responsible for that. So it means temperature is the only answer for this question. Addition of a catalyst, wrong. Increasing the concentration, wrong. Increasing the surface area of the reactant, increasing the temperature of the reaction is the right answer, okay? Because it is fulfilling both the conditions. So this factor, the temperature factor, is actually fulfilling both the conditions. So that's why option D is the right option. 16. The rate of the reaction between magnesium ribbon and 2 mole dm cube of hydrochloric acid. So this is actually the concentration, right? At 25 degree, this is the temperature. To produce hydrogen gas is measured. In other experiment, either the concentration of hydrochloric acid or the temperature is changed. So they are changing these two things. The magnesium ribbon is the same, right? All other conditions are kept the same. Which condition increase the rate of reaction? So it means if you increase the concentration and increase the temperature, the rate of the reaction will increase. So let's see one by one. Before we were using 2 ml. So it means if you increase the concentration, the rate of reaction will increase. So more than 2 is 3, right? So we have to see, okay, this one is the right answer. Or this one can also be. So anything can be right, but this one is wrong because we are decreasing the concentration. Now let's see 25. So you have to increase the temperature from more than 25, right? So where you can see 25 or more. So these are the only two options where we can see. So it means the temperature was same, right? They only increase the concentration of hydrochloric acid. So this option can increase the rate of reaction. This option cannot increase because now the concentration is less. Temperature is same, but concentration is less. Here the concentration is same, but the temperature is again less. So they will decrease the rate of reaction. Only D will increase the rate of reaction. So option D is the right option. Question 17. Magnesium reacts with dilute HCl. Which statement about the particles in the reaction is correct? Increasing the concentration of dilute HCl increases the collision rate but has no effect on the activation energy. Yes, that's right. It will increase the collision rate, but it has nothing to do with the activation energy because concentration will just increase the particles, number of the particles. More particles, so more chances of collision. Increasing the concentration of dilute HCl increases the collision rate and the activation energy. Up till here it's right, but this one is wrong, okay? Increasing the temperature of the reaction increases the activation energy. Again wrong, it just increases the kinetic energy. Increasing the temperature of the reaction causes all the collision to lead a reaction. No, increasing the temperature of the reaction causes most of the collision to lead a reaction, okay? Not all of them. So this one is also not true. So option A is the only right option. Question 18. Which statement about the effect of concentration and temperature on the rate of reaction is not correct? Okay, the effect of concentration and temperature. If the concentration of the reactant is increased, the rate of reaction increases. Okay, that's right. Because more particles have sufficient energy to react. Wrong. This statement is only right for the temperature. Okay, because more particles will collide. That is the right answer. But they say more particles have sufficient energy to react. So this is the only wrong option we have to find. So option A is the right. Option A is the not correct option for this one. So option A is the right option for this question. Okay, but we can still see B, C, and D. If the concentration of reactant is increased, the rate of reaction increases because there are more collision. Yes, that's right. If the temperature is increased, the rate of reaction increases. Yes, because there are more collision between the particles per second. Yes. If the temperature is increased, the rate of the reaction increases because more particles have sufficient energy to react. Yes, it's the only thing that is that is controlled by the temperature factor. Okay, so no other factor control this thing. So that's why the sufficient energy is only the answer for the temperature. So option A is the only wrong option. So we will choose option A. Question 19. Nitrogen and hydrogen can be converted to ammonia, NH3, using a catalyst. What is the purpose of the catalyst? Okay, so the purpose of the catalyst is to speed up the reaction. Okay, so where we can see to increase the amount of ammonia, to increase the rate of reaction. Yes, so the B option is the right option. Which change increase the rate of reaction by decreasing the activation energy? I already told you only this is the job of the catalyst. Catalyst will decrease the activation energy of that overall reaction. If your reaction needs like this much energy to react, now when you will add the catalyst, it may be just need this much energy to produce the reaction, okay, to do. So that's why you see the if you add the catalyst, it will decrease the EA. We did this one yesterday in chapter 7. So you can see that activation energy after adding the catalyst will be decreased. Okay, so but there will be no effect on the product. The product will same, but only the speed of the reaction will increase, so you will get the product in a short time. So increasing what addition of a catalyst is actually responsible for decreasing the activation energy. So option A is the right option. Question number 21. The effect of a change in condition on a chemical reaction are listed. First, the total number of the collisions per minute increased. Okay. The number of effective collisions per minute increase. Fine. The average energy of the particles also increase. So which change in condition call all these effects? These two are for surface area, they are fine. Okay, also for the pressure, if you see, they are fine. For the if you are using what you say concentration, higher concentration, that's okay. But this one is only right for the temperature. So it means temperature is the only right answer for this question, because average energy of the particle increase only when you increase the temperature. So increasing the temperature is the only right option here, option D. Question 22. Magnesium powder reacts with an excess of dilute hydrochloric acid to produce hydrogen gas. Which statement about this reaction are correct? So they are using magnesium powder and excess of the dilute hydrochloric acid. The smaller the particles of the magnesium powder, the more slowly the hydrogen is produced. Wrong. The smaller the particles of the magnesium powder means the rate of the reaction will now increase. So more slowly the hydrogen means the rate of reaction is slow, right? That's why you are getting slowly your product. That's wrong. The higher the temperature, the faster the magnesium powder disappear. Yes, that's right. The reactant will be consumed faster to give you a product when the temperature will be higher, right? The rate of the reaction is increased. The lower the concentration of dilute HCl, the faster the rate of reaction. So the lower the concentration, wrong. The lower the concentration, the lower the rate of the reaction will be. The faster the magnesium powder disappears, okay, the faster the rate of reaction. Yes, that's right, because magnesium is actually your reactant. The more the speed of the disappearing of the magnesium powder, it means the rate of reaction is faster. That's why it is converted into product quickly. So option 2 and option 4 are the right option. That's option C. Question 23. A student investigates the effect of concentration on the rate of reaction between calcium carbonate and hydrochloric acid. So calcium carbonate and HCl is used. He follows the method shown. Place 1 gram of calcium carbonate in a conical flask. Add excess of HCl. Let the reaction continue until no more gas is made. Repeat the experiment with different concentration of the acid. So he is using now different concentration of the HCl. All other changes are same. Okay, he's not changing any other factor. So which essential step has been left out of the method if he is to work out the rate of reaction? So to measure the rate of the reaction, you have to measure the different, okay, he is measuring the different concentration of the HCl. But one thing is, what is the definition of rate of the reaction? It is the speed of the reaction per unit time. But in these steps, they did not mention that where the student is looking at the time, how he is measuring the time. Is he measuring the time, yes or no? So timing of the reaction has not been measured. That's why this method will not work out. Okay, so the essential step has been left out for this experiment. He is not measuring the time, that is time taken to finish that reaction, okay, or to see that how much gas is produced in a particular time. So he's not measuring the time. That's why option C is the right option. Question 24. How does increasing the concentration affect the reacting particles in a chemical reaction? So increasing the concentration always increase the rate of reaction, right? So the collision rate will increase. Yes, that's right. Increasing the proportion of particles with activation energy. So that's wrong. It has nothing to do with the activation energy, okay? It just increase the collision rate because there are more number of particles. So option A is the right option. Question 25. Which row explain why increasing temperature increase the rate of reaction? Particle collides more often. Yes, that's right. Both options are right. Particles collide with more energy. Yes, that option is also right. So option A is the right option. Question 26. Which row describe the effect on the activation energy and the frequency of the particle collision when the temperature of a chemical reaction is increased? Okay. So you have to see two things: the effect on the activation energy and the frequency of the particle collision if you increase the temperature. Temperature has nothing to do with the activation energy. Yes, but the particle collision, it will be increased. Why? Because the kinetic energy of the particles will increase. So now let's see activation energy, no change. Yes, no change. These two options are right. Frequency of the collision, of course, it will increase if you increase the temperature. So option B is the right option. Question 27. Which row describe the effect of increasing both concentration and temperature on the collision between reacting particles? So when you increase the concentration, there will be more collisions per second only, right? More collision per second and more collision with sufficient energy. Again, the word sufficient energy, that is not used for the any other factor. It's only used for the temperature. So this option is wrong. This is right. This is wrong. So now we are only left with A and C. Let's see. In A, more collision per second only? Only. No, that's not only right. Because more collisions per second and also with sufficient energy to react, right? So option C is the right option because it's a complete statement. This statement is not complete. So option C is the right option. Question 28. A chemical reaction occurs when the reactant particles collide. Which reaction conditions would produce the greatest rate of particle collision? Let's see, concentration of the acid. If you increase the concentration of acid, of course there will be more particle collision, right? So increase, this right option is the right option. Now another thing is reaction temperature. So if you increase the temperature reaction, of course the particle collisions will be more. So increase is also again the right option. So option C is the correct option. Question 29. The rate of the reaction between magnesium and dilute HCl is increased by increasing the concentration of the acid. So now, what does this affect the reacting particles? It only increase the collision rate, right? So the collision rate of the particles will increase. That's why the rate of the reaction will increase. Portion of the particles with sufficient energy to react. Sufficient energy is the only product of a factor that is temperature, right? Concentration has nothing to do with the sufficient energy of the particles. So it means it will stays the same when you are increasing the concentration. So option B is the right option, okay? Now let's see question number 30. A sample of dilute nitric acid is added to the lumps of limestone in a conical flask. The conical flask is placed on a balance and the loss of mass is measured. Okay, that's right. Why they are they are reacting the dilute nitric acid and the lumps of the limestone calcium carbonate. And now they place the conical flask on the balance, okay, and then they start measuring the loss in the mass. Why in loss in the mass? Because of course the in the product we are getting a gas. So when the gas will evaporate, the reactant's mass will start decreasing, right? So you can see that, okay, the gas is producing and it is being removed from the sample. That's why now the slowly the mass of the reactant is decreasing, that is in the beaker. So now a second sample of nitric acid of a different concentration is separately tested. All other conditions are kept the same. So only they are changing the concentration, right? So we have to answer accordingly. The loss in mass 1 minute at each concentration of nitric acid is shown. So when they use a lower concentration, the loss in the mass was less, right? But when they use higher concentration, the loss in the mass was higher. What is the mass that is losing? Actually, it's the reactant mass, right? Because reactant is changing into a product. So now you are losing the mass of the reactant quickly. So it means this rate of the reaction is higher because you have used higher concentration. Which row describe and explain the result obtained using 1 mole dm cube compared to 0.5 mole dm cube of of the nitric acid? So if you have two statements and you are confused that I have to answer accordingly 0.5 or 1, so see they are actually asking about 1. Explain the result obtained in 1 mole dm cube. Okay, so your answer should be according to 1 mole. So in 1 mole the rate of reaction is higher. Okay, so we have to see, okay, increase in the rate of reaction. There is an increase in the rate of reaction. Why there is increase? Because there is increase in particle collision rate. Increase in particle collision rate and collision energy, that's wrong. It's only for the temperature, I already told you. Okay, so that's why option C is only the right option. Question 31. Calcium carbonate was reacted with HCl hydrochloric acid in a conical flask. The flask was placed on a balance and the mass of the flask and the contents were recorded as the reaction proceeded. Okay, so this is the same experiment. They are just measuring the loss of the mass by measuring it on the balance. Okay, during the reaction, carbon dioxide gas was given off. The reaction was carried out at two different temperatures. Which row is correct? Change in the mass. So if there are two different temperatures they are using, so the change in the mass will be higher or lower. Of course, the change in the mass will increase, because if you are using two different temperatures, so if the change in the mass is increasing, okay, sorry, change in the mass can decrease and also increase. If you are using low temperature, it can decrease, right? If you use high temperature, it can increase. So any statement can be right, but what is the reason behind it? Temperature at which the mass change more quickly. If the temperature at which the mass change more quickly, it means that temperature is the actually the higher temperature, right? So the mass, if the mass change quickly, then it's a higher temperature. Okay, for example, if it's a higher temperature, then your change in the mass should be increased, right? So you have to see this answer, that high temperature should be with increase and lower temperature should be with decrease, right? So we see any statement here? Yes. So the temperature at which the mass change more quickly means the rate of reaction has been increased. Because if the, wait a minute, let me explain again this. The reaction was carried out at two different temperatures, right? They are using two different temperatures and they are saying which row is correct. Change in the mass can be decrease or increase, it depends. But we have to see this one, temperature at which the mass change more quickly. So when the mass is changing more quickly, it means what happens? Actually, the mass of the calcium carbonate they are talking about. Calcium carbonate is a reactant. So if the mass is changing more quickly, it means actually it is consumed quickly. Consumed quickly means the rate of the reaction is actually increased. So who can increase the rate of the reaction? High temperature or low temperature? Of course, higher temperature can increase the rate of reaction. So when there will be high temperature, the change in the mass will increase. Okay, so the change in the mass will be more. The change in the mass will be more, but they are not asking the change in the mass will. Okay, so now we can see that when the change in the mass, because the calcium carbonate is formed, so you will see a decrease in the mass, because before in the start the calcium carbonate was higher, right? CaCO3, and slowly it is reduced. Okay, slowly it is reduced, and if you see per unit time and if you increase the temperature, so then the reduction will be more quicker, like this. In this second you can see, so the calcium carbonate will reduce quickly in its mass when there will be higher temperature. Okay, so the change in the mass will decrease. Option A is the right option. Question 32. The equation for the decomposition of hydrogen peroxide is shown. In an experiment, the total volume of the oxygen produced is 100 centimeter cube. Okay, and the experiment is repeated using 1 gram of solid catalyst. All other conditions remain the same. So this question is related to catalyst. Before, this reaction is without catalyst, and now the question is after catalyst. Which row describe the total volume of oxygen and the mass of the catalyst at the end of the second experiment? So what will happen to the volume of the oxygen? The job of the catalyst is to speed up the reaction. Okay, to speed up the reaction, it has nothing to do with the product mass or the volume of the product or the concentration of the product or the moles of the product, right? So if you are getting 100 centimeter cube of the oxygen, 100 volume of the oxygen, it will remain the same, only the time will be less, right? If you are getting 100 centimeter cube of the oxygen, in 10 seconds, maybe now you will get in 5 seconds because you are using a catalyst. Okay, so but the volume will remain the same. So volume of the oxygen, it has nothing to do with, okay, it will not change the product mass or the volume, anything. And also the mass of the catalyst, because catalyst is any compound that only speed up the reaction, but what will happen to its mass? It mass remain unchanged at the end. So there will nothing will happen to the mass of the catalyst and also the volume of oxygen. So what is the volume of oxygen? 100. So it means it will remain the same. And what about the catalyst? Catalyst we use 1 gram, so it will also remain the same. So option C is the right option. Question 33. Let's see. Hydrogen peroxide decomposes to form water and oxygen. Manganese oxide catalyzes the decomposition reaction. The reaction is investigated in 4 experiments, right? So all reaction go to completion and all the measurements of gas volumes are at room temperature and pressure. Which statement is correct? Okay, so hydrogen peroxide that was used, okay, this is your reactant. How much volume and concentration they are using? The volume is 12.5 and here the volume is more, right? So, but here the concentration remains the same. But what's happening actually? The concentration here is more. So just look at this one in which the concentration is more. And let's look at these two options. This is rejected because we already have like less concentration and less volume. Okay, so we can reject this one. But here the concentration is, the volume is more and the concentration is 1. Okay, so these three we can see now one by one. Okay, now let's see the conditions here. 40 degrees Celsius with manganese oxide powder added. Okay, here without manganese oxide powder, so the temperature is 40. Okay, temperature remain the same. Here the temperature is also less. Okay, this reaction will be the lowest reaction rate. It will have a lowest reaction rate. Okay, and this one, if you see, the temperature is same for all, but in this one we have catalyst, yes, right? In this one no catalyst, and in this one we have also catalyst. Now let's see one by one. Experiment 1 produces less gas than experiment 4 but at the same rate. If you see experiment 4, okay, yes, experiment 1 will produce less gas. Can you see here? Okay, because the volume of the volume of the gas will depend on the volume of your reactant. Also the volume of the like product will depend on the volume of the reactant. So the volume of the reactant is less right here, so it means it's right. Experiment 1 will produce less gas than experiment 4, right? But the same rate, same means the reaction rate will be same. That we can see now. 1 mole the concentration was same, right? So 1 mole means the rate of the reaction will same for this one. But let's see about this condition. They use lower temperature, but here they are using high temperature. So it means high temperature will increase the rate of reaction for this experiment number 4, right? So that's why this option is not the right option, because the rate will not be the same one. Now let's see option 2. Experiment 2 produces more gas than experiment 1. Experiment 2 is producing more gas than experiment 1. Wrong, because they both have the same volume, so it's not possible, right? So, but at the same rate. Okay, at the same rate, can you see, is this possible that if you have added the same rate? No, and not at the same rate, because the concentration is higher, right? When the concentration is higher, the rate of the reaction, of course, for this one will be higher. And also the temperature is higher. Here the temperature is lower, so this option is also wrong. Experiment 2 and experiment 4. Experiment 2 and experiment 4 each produces the same volume of gas. Now let's see to this one, experiment 2 and experiment 4. Okay. If you see here the volume, and here we have volume and concentration. So if your volume is 12.5 and it is 2 mole dm cube, right? So what will be the number of moles if you find? And it is 25 centimeter cube of 1 mole. So you remember the mole formula. Mole is volume into concentration, right? So it will be same. How much is the? We have 25. Here 12.5 into 2 is also 25. So the number of moles is same. What does it mean? It means now that the same volume of the gas will be produced, because the moles are same for both the reactants, right? Because one is the volume is less but the concentration is double. Here the volume is double but the concentration is half, so it means the number of moles are same. So it means this option is right. Experiment 2 and experiment 4 each produce the same volume of gas. Now but let's see this one at the different rates. So this option is giving you the same volume of the gas, right? But different rates we can see. 40 degrees with manganese powder added, 40 degrees with manganese oxide powder added. So these two options were right, okay? But here if you see the concentration is more, the more concentration means the more will be the higher will be the speed of this reaction. So in option 2 the number of moles are more, right? Sorry, the concentration is higher. Higher concentration means it will increase the rate of reaction. So that's why the concentration rates are different. That's why option C is the right option, okay? Let's see option number D, why it's not right. Experiment 3 and experiment 4 each produce the same volume of gas. 3 and 4, yes, they produce the same volume of gas and at the same rate. Why not same rate? Because if you see, without manganese, they are not using the manganese powder, but here they are using the manganese powder. Okay, so that's why this option is also wrong. So option C is the only correct option. Question 34. A liquid X reacts with solid Y to form a gas. Which two diagrams show suitable methods for investigating the rate of the reaction? Okay, so you want to measure the rate of the reaction. So the thing is you have to see how much product is made per unit time. Okay, the product made per unit time or the reactant consumed per unit time. Okay, so we have to see here if you want to. Okay, let's see one by one here. They are measuring the gas volume, right? Because the gas is produced maybe in the product, right? So if the gas they are measuring, then they should close this one, right? If they will close this one, then the gas will not evaporate, okay, or it will not move out. So it means they are not measuring the right volume of the gas, because half of the gas will go out from here. So that's why this is not acceptable. Here let's see. Here the volume of the gas will evaporate, right? The gas will move out from the flask. But we have a balance here. So this balance will actually measure the reactants consumed, right? The reactants will now get lower. It was 44. After 5 minutes, maybe it becomes 40. That 4 moles is actually, the 4 grams is actually given out in the form of a gas. So it means this experiment is right. You can measure the time, measure the change in the mass per unit time, that how much mass is decreasing for the reactant after different time of the intervals, right? So this option is the right option. Let's see this one. They have used a stopper here, okay, like this one, but how they will see the change in the mass, because the gas cannot go out and they have not used anything to measure the gas volume. So this option is also wrong. Let's see this one. They have used the stopper here. Okay, so the gas cannot go out, but they can measure the gas volume here in the syringe. So it means, and they are not using the balance. They don't need the balance. So they are actually measuring the product made per unit time. So this option is also the right option. So option 2 and 4 are the right option. Where is that 2 and 4? That is option D. Okay, option D is that's why correct. Question 35. A student was investigating the reaction between marble chips and dilute HCl. Which change slow down the rate of reaction? So what thing will slow down the rate of reaction? Let's see, temperature of the acid. Of course, if you decrease the temperature, the rate of reaction will decrease. So that's why decrease is the right answer. Decrease is right. Concentration of the acid. You have to decrease the concentration of acid, then the rate of reaction will also decrease. So decrease is the right answer. Surface area of the marble chips. If you increase the surface area, the rate of reaction will increase. So if you decrease the surface area, the rate of the reaction will decrease. So option A is the only right option here. Question 36. The apparatus shown is used to measure the rate of the reaction. Okay, they are using to measure the rate. It means the gas syringe, the product will be your gas. Okay, and these are your reactants. Which equation represent a reaction where the rate can be measured using this apparatus? So it means this apparatus we can only use if in our product we have a gas. So let's see in which reaction we have a gas as a product. So if you see, this is the only reaction in which we have a gas. All other reactions don't have any gas, so only A option is the right option. Question 37. An experiment X is carried out between a solid and a solution using the apparatus shown here. The volume of a gas given off is measured at different times and the results plotted on the graph. In second experiment Y, the surface area of the solid is increased, but all other factors remain the same. So now they are increasing the surface area. So what does it mean? Increasing the surface area will increase the rate of reaction. So it means experiment Y, in experiment Y, you will see the increase in the rate of reaction. So Y should have a higher slope, okay? So it should be more steeper. The graph should be more steeper. So it means you see here X, right? But if you see the surface area, so increasing the surface area will only increase the rate of reaction, but not the volume. At the end, the product will be same, right? So first of all, you have to see the product should be same. So if you see here the X, you see the volume of the gas is more here, here it is less. Here it is less, here it is more. So it means these two are wrong. The volume should be same, right? So these two are the right options. Now we have to see that in which experiment the rate of reaction was faster. So more steeper means more faster. So here we have used the surface area was increased, right? So it means experiment Y has the highest rate of reaction. So Y should have more steeper. So it means which one is the right one? This option is the right one, because in small time, if you see, it is giving you more volume of a gas, but here in small time it is giving you less volume of a gas. If you can see, it's just up till here, right? And the distance is more. Here in a small distance you get more volume. So it means option B is the right option. Question 38. The volume of a gas given off in a chemical reaction is measured over time. The results are shown here. At which time the rate of the reaction was greatest? It's simple. If you see from 0 to 2, it's still at 0. But from 2 to 4, it's like how much? Almost 9 is produced, right? And then if you see from here to here, from 4 to 6, like how much is produced? Here. So from 10 to almost 40. So you see a higher volume is produced between 4 to 6. So this one is the right option. 6 degrees Celsius is the right option. The rate of the reaction is the faster one here now. But here if you see for the 10 degrees Celsius, 10, they have given you the option. At 10 the reaction has already stopped. So if you see from 8, where the 8 is ending here. So from 8 to 10 it's just small, right? But here the slope is more steeper. So this is the 6 second is the right option, option C. Question 39. The reaction between two aqueous compound X and Y is slow and exothermic. The graph shows how the rate of the reaction changes with time. A student suggests that rate of reaction decreases with time because the activation energy decreases. Wrong. Activation energy of the reaction always remains the same, right? Only if you add a catalyst. We are not adding a catalyst, so how it will decrease? The rate of the reaction decreases with time, okay, because the speed of the molecules of X and Y decreases. No, the speed of the molecules has nothing to do with the rate of the reaction when there is no temperature involved, right? So the speed of the molecules depend on the temperature. They are just talking about a normal temperature, normal reaction, okay? So this is also not right. The concentration of the both X and Y decreases with time. Yes, that's right. The concentration of the particles slowly decreasing at the end of the reaction. That's why, because in start we have more number of particles, right? So the reaction will be more faster, but slowly all these particles are consumed to make a product. Now we will have less number of particles left in the reactant. That's why slowly the reaction, because with time the reaction becomes slower. That's why option D is only the right option. Okay. Question 40. An experiment is carried out to find the rate of reaction between HCl and zinc. This is the reaction. The result of experiments are shown. What is the label on y-axis? First of all, you have to see where the y-axis is starting from. It's starting from the top. It means at the start something was very high and slowly it is getting lower. So what does it mean? It means it can be a reactant, because of course in start we cannot have a higher number of the product. If they are measuring a product, the plot should be like this one. But here the plot is like this one. It is coming below. It is coming down, right? So it means in start we have a higher thing, anything that was higher in number, and now slowly with time it is reducing. So it means it's actually a reactant. They are measuring a reactant. So it can be HCl or it can be zinc. Now let's see where we can see the word HCl and zinc. So these two options are rejected. Only these two can be right. Now let's see concentration of HCl or mass of zinc reacted. Okay, so if you plot the graph for zinc, for example, if you think it is for zinc, then slowly the zinc will reduce. So the remaining zinc, okay, this is the remaining zinc that is showing on the graph. But they say the mass of the zinc that has already reacted. So then the graph should always be again like this, because in start it was useless. The mass of the zinc was less that was reacted, and slowly it becomes more and more zinc reacted, right? But here they are saying that it is reducing, right? The graph is showing a reduction. So it means actually the concentration of HCl is reducing now slowly because it's more consumed. So that's why this graph is actually showing on y-axis the concentration of the HCl. Option B is the right option. Question 41. Excess dilute HCl is added to equal masses of powdered calcium carbonate in two separate experiments. Two different concentrations of HCls are used. The temperature in both experiments is same. The result shows the change in the mass of the reaction flask measured over time. So only what they have changed actually the concentration of the HCl. So now we have to see what is the rate of the reaction of 1 mole per dm cube. Why is the rate of the reaction for the 1 mole dm cube hydrochloric acid is slower? If you see the rate of the reaction is slower for this one because the slope at this time, for example, at this time, it's making how much the mass of the flask is here. But if you see at the same time, the mass of the flask is now less. So what does it mean? It means more reactants are consumed in this experiment where we use 2 mole dm cube. So the rate of the reaction is higher here, okay? So what is the reason behind it? Collision energy. Okay. Collision energy, okay, what is the rate of reaction for 1 mole dm cube? We have to see. So the collision energy is same or lower? Of course it is same as of 2 mole dm cube because collision energy has nothing to do with the concentration. Okay, so there is nothing change in the collision energy even if you increase the concentration or decrease the concentration. It's the job only of the temperature, yeah, okay. Only the factor temperature is responsible for changing the collision energy, increasing the collision energy. So that's why option C or D can be right. Now collision rate, yes, the collision rate of 1 mole of dm cube is lower, that's why the reaction is lower. So the collision rate is lower, that's why the rate of the reaction is lower. So option D is the right option. Question 42. HCl is added to excess calcium carbonate in two separate experiments. Two different concentration of hydrochloric acid are used, but temperature is the same again. Okay, the graph of the results show the volume of carbon dioxide given off over time. So these two questions are same, but here they were measuring the reactant, and now here in the question 42 they are measuring the product, the carbon dioxide that is produced, right? So if you see here, in 1 mole dm cube, the rate of the reaction is slower, right? For example, at this time you are just getting this volume of a gas. But if you see here, at the same time you are getting this much volume of a gas, right? So it means 2 mole of the dm cube is giving you higher volume of a gas. So which row is correct? Particles in 2 mole dm cube compared to 1 mole. So you have to compare the particles in 2 mole dm cube. Your answer should be according to 2 mole. So collision rate is higher. Yes, it's right. What about collision energy? No change in collision energy because concentration has nothing to do with the energy. So only the collision rate is higher. So option A is the correct option. Question 43. The rate of the reaction between magnesium and excess dilute HCl was followed by measuring the mass of magnesium present at a regular interval. So it means they are measuring the reactants, right? Okay. Two experiments were performed. Both experiments used 0.1 gram of magnesium ribbon. Okay, it's same. The acid of in experiment 1 was less concentrated than in experiment 2. So, but the HCl, the acid that was used was less concentrated in experiment 1. So experiment 1, it was less concentrated. So in experiment 2, it means it was highly concentrated. So the rate of the reaction will be higher in experiment 2. Clear? So now let's see one by one. Which graph shows the result of the experiments? First of all, because there is only change in the concentration, so the product should be the same. The product should not change. So if you see, the products are same, right? Okay, so also the rate of and was followed by the mass of the magnesium present. They were actually measuring the mass of the magnesium present. What does it means? That the remaining mass they were measuring. So in start, if it was, for example, 40, slowly they were measuring that how much is left. Okay, they are not looking at the reacting mass, they are looking at the remaining mass. So when they are looking at the remaining mass, in start it was more and slowly it becomes less, right? So this should be the type of the graph. If they say that they measure the mass of the magnesium reacted, so it means in start the magnesium reacted was less and slowly it becomes more, right? Because the reaction will become faster, so the magnesium will also like react more with the passage of the time. So now you have to read this question very carefully. Measuring the mass of the magnesium present at regular intervals. So the leftover mass you have to check. So that's why these type of graph will be the right graph. These are wrong. Okay, now let's see. Higher concentration is in experiment 2. So your experiment 2 will have a steeper graph compared to 1. So let's see in which one you have in short time you can have more mass, you can still have less mass. Okay, so we have to see. So this is the shortest time, right? In this time the mass remaining is this much, but at the same time the mass remaining in experiment 1 is here, right? It's more in here. So what does it mean? That's why option A is the right one. It means that in experiment 2 the speed is higher, right? Because the mass is remaining less. Why? Because it is more consumed, is more quickly consumed. But here you are writing 2 here. What does it mean? It means that at this time, for example, I want to measure, so your mass that is consumed at this time was this much, right? From here to here. But here, if you see at the same time, in experiment 2, it was less steeper, right? It was still more. So it's not possible because there is a higher concentration of and it's a high concentration of HCl in experiment 2. So the rate of the reaction should be higher. So that's why option A is the right option. Question 44. The mass of the beaker and its contents is plotted against time. Which graph represent what happens when sodium carbonate reacts with an excess of dilute HCl in an open beaker? So when they are using the open beaker, of course, the gas will evaporate. It will go out of the beaker. So the mass of the beaker will slowly getting less, right? So they are measuring the mass of the beaker, so it will slowly getting less and less. So in start it will be more and then it will less. So where in start it is lower, yes, it is higher, but it is getting more higher, which is not possible. It should get lower. So this mass, this graph is the right graph. This graph, it's same, so it's not right. Why this one? This one is actually not practical. It's not possible. The mass usually decrease gradually, not like just like this one. Okay, so this is not a practical graph, or it's not related to the reality. So that's why option B is the only right option. Question 45. In excess of calcium carbonate reacts with dilute HCl, the volume of carbon dioxide produced is measured at a regular time intervals. The results are shown here. So the experiment 1 is repeated only with one change to the reaction conditions. The results are shown as experiment 2. Okay. So this was the first experiment in which calcium carbonate react with HCl. And the volume of the carbon dioxide they have measured. It means they are measuring the product. Which change is made in experiment 2? So if you see the experiment 2 is the slope is more steeper, right? Second, the product is also different. If you see, the product is not the same. The volume of carbon dioxide is more compared to the volume of the experiment 1. In experiment 1, the carbon dioxide. So what does it mean? It means the volume of the acid has been increased. It's not only about the concentration, because if you increase the concentration in experiment 2, the rate of the reaction will increase. It will be like this, okay? it will increase, but at the end the product will be same. Okay, so it has nothing to do with the concentration only increase the rate of the reaction. But here actually the answer will be the volume of the acid is increased. Why the volume of the acid is increased? That's why you are getting what? You are getting higher number of the carbon dioxide, higher volume of the carbon dioxide also. So that's why option B will be the one that you have to choose, not the concentration option. Question 46. In experiment 1, small lumps of limestone are added to the dilute ethanoic acid at 40 degrees Celsius. The volume of carbon dioxide release is measured at regular time intervals. A graph of the result is shown here. Okay. So in experiment 1, they use the 40 temperature. So which changes give the result shown in experiment 2? So if you see the experiment 2 is giving you the same product, right? So it means you have changed nothing with the concentration, or like you have not changed the volume, sorry. The concentration may be changed, but the volume has nothing to do with it. But the second thing, if you see here, so the slope is like less steeper as compared to the experiment 1. It means in experiment 1 something has been decreased. That's why the rate of the reaction is lower compared to experiment 1. So we have to see now which changes give the result shown in experiment 2. Limestone. Before they were using small lumps of limestone. It means now maybe they have used large lumps of the limestone, right? So large lumps of the limestone may be used. Okay, powder is not possible, because if they use the powder, then it will have be, the rate of the reaction would have been higher, but here it is lower. So small lumps, no. Now temperature. So the temperature can be lower. Okay, they have maybe lower the temperature. So if you see, if they have you, they heat is increased, so it means that's wrong. If they increase the temperature, the rate of the reaction will increase. So it means the temperature remain the same, but only they use the large lumps. That's why the surface area was getting smaller. When the surface area was smaller, the rate of reaction decreased. That's why the rate of reaction decreased in experiment 2. So option A is the right option. Question 47. A student adds excess zinc to dilute HCl at 25 degrees Celsius. The hydrogen gas produced is collected and measured at room temperature and pressure. The results are plotted and labeled as curve X. Okay, so this is our curve X. This is the main experiment we have. Okay, the experiment is repeated at 50 degrees Celsius with all other conditions remain the same. So now when the conditions remain the same, the graph should have which graph shows the result of 50 degrees. So you are increasing the temperature, right? So the volume should remain the same. The product volume should remain the same, right? Only the rate of the reaction will increase. Temperature will increase the rate of the reaction. It has nothing to do the product size or the product mass, right? So the product mass will should remain the same. So this is your X, your product is here. So it means only B or C option can be right, because they have the same product mass. The volume of the hydrogen gas is same in B and C. Here, the mass is more. Here, the mass is less. That's wrong. Sorry, the volume. Sorry, the volume of the hydrogen gas is less here. So it means it's wrong, okay? So now only B or C option can be right. But let's see which option, B or C. B is showing that the rate of reaction is higher. C is showing that the rate of reaction is lower than X. But we have used a higher temperature. It means the high temperature will have a higher rate of reaction, right? So B option is the right option, because it has higher rate of reaction, or the rate of reaction is more than as compared to that of the X. Okay, so option B is the right option. Question 48. The result of adding excess marble chips to hydrochloric acid at 50 degrees Celsius and 30 degrees Celsius are shown here. Only the temperature is changed. Which row described the reacting particles at 30 degrees Celsius compared to that of the 50? So your answer should be according to 30. So in 30, the collision rate is actually lower, right? Why lower? Because the collision energy is also lower. So option D is the right option, because you have to answer according to 30. In 30, the rate of the reaction is lower. Why? Because the collision energy is also lower and the collision rate is also lower. Question 49. The rate of the reaction between calcium carbonate chips and HCl is studied by collecting the volume of the gas increase in 1 minute at different temperatures. A graph of the reaction against temperature is shown here already. Okay, the rate of the reaction and then the temperature. Which statement fully explain why increasing the temperature has this effect on the rate? So increasing the effect, let's see, the kinetic energy of the particle increases. Yes. So the collisions are harder. That's wrong. Collision will be more easier now. Okay. The number of collision between particles increases. Yes, the number of the collision between particles will increase when you increase the rate of reaction. But you have to read all the statements. The activation energy need for the particles to react is reduced. Wrong. Temperature has nothing to do with activation energy. There are more frequent collision between the particles with enough energy to react. Yes, that's also right. So which one is more better, B or D? Of course, D, because it is a complete statement. It's also telling that now the particles have enough energy to react. That's why there are more frequent collisions. Okay, so that's why option D is the right option. Question number 50. Zinc granules are reacted with excess dilute HCl. The volume of hydrogen given off is measured at different times. The results are shown on the graph labeled experiment 1. Okay, the result for a second experiment also shown on the graph labeled experiment 2. So experiment 2 has a lower rate of reaction, right? Lower rate of reaction. And the experiment 1 speed is higher, right? So the rate of reaction is increased in experiment 1. In experiment 2, it is reduced. So let's see which change to the condition was made in experiment 2. So what happened that why the experiment 2 has lower rate of reaction? Which change they have made? So our answer should be according to the reduction. The concentration of the hydrochloric acid was decreased. Yes, that can be the right answer. The size of the zinc granules was decreased. If you decrease the size, what will happen? The surface area will increase, and if surface area increase, the rate of reaction will increase. But here the rate of reaction is decreased, right, in experiment 2, so this option is wrong. The surface area of the zinc granule was increased. So when you increase the surface area, of course the rate of reaction will increase. So this is again wrong. The temperature was increased, again wrong, because if you increase the temperature, the rate of reaction will increase. But in experiment 2, the rate of the reaction has decreased. So option A is the only left option that is right. Question 51. Solution of acid R and S have the same concentration. The same volume of each acid at the same temperature is reacted with the same mass of the magnesium ribbon. So the concentration is same, temperature is same, mass is same, but you see the graph is different. The volume of the hydrogen gas produced is also same because the concentration is same and the mass. So why the volume of the hydrogen is same, but why the rate of the reaction is now different? Okay, so what can be the possible reason? Let's see. Acid S reacts faster than acid R. Yes, we know that acid S reacts faster. No, wrong, because acid S is like have a lower, you see, the lower rate of reaction. The final volume of hydrogen produced in each reaction is different. Wrong, they are same. You see, the final product is same. These two lines are touching each other. Acid R is a stronger acid than S. R, the rate of the reaction is higher. So it is possible that it is a strong acid. That's why it is releasing more hydrogen ions into the solution. So more hydrogen ions means more reaction, more product will be formed. So that's why, the rate of the reaction will be increased. So that's why this option can be possible. Acid S is stronger acid than R. S is not stronger because the rate of the reaction is lower compared to R. So that's why option C can only be the right option. Question 52. Dilute HCl is reacted with excess calcium carbonate and the total volume of the gas is measured at regular intervals. The results are shown by line W and on the graph, the results are shown by line W on the graph. The experiment is repeated but with one change. The result of the second experiments are shown by line X. So this is second experiment, this is one. So it means the second experiment has reduced, right? The rate of the reaction has been reduced. So now let's see which change is made in the experiment 2. A catalyst is added. If a catalyst is added, then the rate of the reaction should increase, but it's not increase, it decrease. The calcium carbonate is broken into smaller pieces. Again, it should increase, but it is decreased, so that's not wrong, right? The concentration of dilute HCl is increased. If it was increased, it should be above, but it's again, okay, wrong. The temperature of dilute HCl is decreased. Yes, that's possible. That's why if you decrease the temperature, the rate of reaction will decrease. So option D is the right option. Question 53. A student investigates the rate of the reaction between marble chips and HCl. The loss in the mass of the reaction flask is measured. The graph shows the results of the two experiments P and Q. Which changes explain the difference between P and Q? A catalyst is added in P. P, if you see, the Q has faster than the P. Okay, if the reaction, if the graph is like from top to the bottom, then below line means the reaction is faster. Okay, remember that. If the line is from bottom to the top like this, so which reaction is the faster one? Of course, this reaction will be the faster one. Okay, this reaction will be the slower one. So, but if this coming from the top to the bottom, so it means this reaction is faster. So Q is a faster reaction, okay, because it's more steeper. If you see, it's more steeper as compared to that this one. This one is like this. You see, the triangle is bigger for the P, but for Q it's just a small, it's the steeper, it's less steeper, right? So this is your Q, this is your P. So this reaction is faster, Q. A catalyst is added in P, so it's wrong because the rate of the reaction is slower here. A high temperature is used in the P, again wrong, because if it was higher then it should be more steeper than Q. Bigger marble chips are used in Q. Yes, that's okay. No, bigger marble chips, if used in the Q, the rate of the reaction should be lower, but here it is higher, okay? So that's also wrong. Hydrochloric acid is more concentrated in Q. Yes, that's possible, that if higher concentration, it means the rate of the reaction will increase. So that's why the Q has higher rate of the reaction. So option D is the right option. Question 54. A student add excess magnesium ribbon to 10 centimeter cube of 0.5 mole dm cube of the sulfuric acid. The hydrogen gas produced is collected and its total volume is measured every 10 seconds. The experiment is repeated with 5 centimeter cube of 0.5 mole per dm cube sulfuric acid added to 5 centimeter cube of the water using the mass of the magnesium, same mass of. So now only the first experiment, if you see, we have 10 centimeter cube. It means the volume was 10 centimeter cube and 0.5 moles of the sulfuric per dm cube of the H2SO4 was used, right? In second experiment, 5 centimeter cube, okay, and with 0.5 mole per dm cube of the H2SO4 was added into 5 centimeter cube of the water. So what it means? It means now the volume was 10 centimeter cube for same. So they had the same volume, but concentration is now reduced because it was 0.5, but when they added the same amount of the water again, so the concentration is now 0.25 mole per dm cube, right, for experiment 2. Now see which line of the graph shows the result of the second experiment. Now in second experiment, if you see, the volume is same, right? When the volume is same, it means the product will be same, okay? Product should be same. So if you see your experiment, this is the original experiment in the dotted line, right? So your product should be same. It should also touch the volume of the hydrogen gas should touch these dotted lines. So it means B or C option can be right option, right? Now we are left with the speed of the reaction because the concentration of experiment 1 is more. So this dotted line should be more steeper. So option C is the one that is showing that the rate of reaction is lower. So option C is only the right option and option B is not correct. Okay. So option C is the right option here. Option C. Yes. Option C is the only right option here because we have now less number of the okay, the concentration will be less, the volume is more. Yes, so it's the volume is same, the concentration is less, so option C is the right option, okay, not D. Okay, question 55. An excess of calcium carbonate is added to dilute HCl X. The carbon dioxide gas given off is collected and its volume recorded at regular time intervals. Line X on the graph shows the result obtained. The experiment is repeated using dilute HCl Y. Line Y on the graph shows the result obtained. Okay. Which statement about the two hydrochloric acid samples X and Y is correct? Now, if you see the rate of the reaction is higher in the Y experiment, right? So, higher rate of reaction and here the lower rate of reaction, but the end product is same, right? So, now they had the same volume, okay, but Y has a higher concentration. Y has a higher concentration, okay? So, when the Y concentration is higher, the rate of the reaction will be higher, of course. But the volume is, if the volume is same and the concentration of HCl is higher, then it's not possible to have the same product. Okay, if the volume is not same and the concentration, because they are same, right, that we are using dilute HCl. So if the volume is not same, okay, if the volume is, or you can say the volume is same but the concentration is different, then the product cannot be same, because if you see, the number of moles is equal to volume into concentration. So if anything change, if concentration change, you also have to change the volume to make up the same number of moles. Okay, so if they had the same volume, then Y had higher concentration, you cannot get the same product. So this option is not right. They had the same concentration by Y, but Y had a larger volume. They have, no, they don't have the same concentration, because the rate of reaction depends on the concentration. So Y has higher concentration. Only Y concentration is the right answer. The X had a higher concentration, wrong. Y had a higher concentration, yes, that's right. But X has a larger volume, yes, this one is right. So option D is the right option. How? I can explain it. Because if you see, if Y has, for example, 1 mole dm cube of concentration, right? And X, of course, has a smaller, it's 0.5 mole dm cube, right? But if they have same volume, that is 1 dm cube, for example, both have the same volume, then what will be the moles? For X, the moles will be concentration into volume. The moles are 0.5 moles. Y moles will be 1 mole. So if the mole number is different, how they can give you the same volume of a gas? That's why option D is the right option. And same is for question number 54. Option D is actually the right option. Okay, my mistake. Option D is the right option. Why? Because if you see here, sorry, option D is the right option, because according to them, if they use, okay, the same number of the volume is same, right? If they are using the same volume, and then what will happen? 0.5 mole of the cube is used, right? So 1 is 0.25, right? So what will be the number of moles? 0.25 into 10 centimeter cube, right? For example, if you convert them, you will still have 0. Okay, you can just assume it. Wait a minute, I can change it into, okay, I can do this one again. Okay, we have one, the experiment, original experiment has how much? The moles, 10 centimeter cube, okay, and then we have 0.5 into 0.5 mole per dm cube, right? And the second experiment has same volume, because, okay, 10 and then 0.25 mole per dm cube, right? The concentration is 0.25. So if you look at these two, which one will have the smallest answer for the moles? Of course, this one. This one, if even if you cancel, it means you have the moles are 0.5 here, and here we have moles is 0.25. It means the volume will also be less here. You will get a smaller volume of your product. So the hydrogen volume will be smaller. You can see here. So it should not touch the graph. So option D is the only right option. The concentration will decrease the rate of reaction. So C or D is right, right? But it will not also touch the same volume, because the moles are less in the, which one? Of course, in the experiment D. So moles are also less, and also the concentration is also less. So that's why option D is the correct option. Okay. So we already covered this one, question number 55. Question number 57. Magnesium is reacted with the dilute acid. The hydrogen gas is collected and its volume is measured. The results are shown on the graph. Between which time was the reaction fastest? So we can just see here from 0 to 1, the slope is like this. From 1 to 2, it's like this. And then from 2 to 3, if you see, it's more, sorry, not here, it's more steeper, right? 2 and 3, it's more steeper, and then from 3 to 4, it's like this. So you see which one is more steeper? This one. So 2 to 3 is the right answer. Option C is the right option. So this is all the questions related to chapter number 8. And then I will come tomorrow again for chapter number 9. Up till then, see you. Bye-bye.